Hello and welcome to a run through of the AQA practice paper set 4. We're looking at the higher tier paper 1 non-calculated paper. Hopefully you're going to find this a more useful way of running through mocks. It's supposed to be beneficial to you so that you can kind of fast forward to questions that you wanted to review first, but also a more comprehensive guide as to what you should have done for each question, because you can look at each question in a lot of detail, or you can look in every question in a lot of detail as part of your revision. So, paper 1, question 1 will be on the highest common factor of 4x squared y and 8xy cubed. Well, first of all, if we break down our two terms here and here into the number part, so 4 and 8, and find the highest common factor of these number parts, that might help. So the factors of 4, as with any number above or below 1, the factors, the integers, the factors of 4 are 1 and itself, so 1 and 4. However, 4 is a square number made by obviously 2 squared, therefore it also has the factor of 2. This means that as it's a square number, it has an odd number of factors. Only square numbers have an odd number of factors. In this case, for 4, it's 1, 2, and 4. For 8, again, it will have the factors 1 in itself, so 1 and 8. But it'll also have a couple of other factors, because 8 can be made by multiplying 2 and 4. Okay, so we're looking for the integers that multiply together to make our target numbers. So our target number was 4, our target number was 8. It can be made by 1 times 8 and 2 times 4. Our common factors are 1, 2, and 4, as they are the factors that are in both lists. So 1, 2, and 4 are common factors. But we're concerned with the highest common factor, and the highest common factor is the highest of the factors that are common, which is 4. So our answer has to have a 4 at the start. Now, you might be able to see which one it is already, but the questions that might come up in the future exams will probably be a bit harder than this one, as this is question 1A. So we need to know how to deal with the x squared y and the xy cubed part. For that, we need to think about how we would do this if we were dealing with just the algebra part. Well, for the algebra part, you have to think, well, x squared and x, they are the x parts of our two terms, and we need to think about what is the least of each letter. What is the least of each letter? So we have x squared and x. So we have two lots of x multiplied together and one lot of x. So we have at least 1x. For our y's, we have a y and a y cubed. So this is made up of just y by itself, and this is made up of y times y times y, so 3 lots of y. So they have at least 1 y. 4xy must therefore be the answer. Circle the lowest common multiple of 4x squared y and 8xy cubed. So we need to think about this time the lowest common multiples of 4 and 8. So our 4 times tables, 4, 8, 12, 16, and so on and so forth. For 8, it would be 8, 16, 24, 32, so on and so forth. So our common multiples in this list anyway are 4. Our common multiples are not 4. Our common multiples start off with the number 8. So we have 8 in both lists. We have 16 in both lists. And if we carried on, then we would have many more. However, we're concerned with the lowest common multiple. So the lowest common multiple is the first number that you reach in both of these numbers, target numbers times tables, which in this case is going to be 8. So our answer must have an 8 at the start, which limits it down to these two. If we're thinking about our x squared and our x's, we need to find the lowest of the common multiples. So if we went in the x squared times tables, it would be x squared, then x4, then x6, then x8, so on and so forth. So the first term in these times tables will be x squared. If we were thinking about the y and the y cubed times tables, y would start off as just y, and then we multiply it by another y to make it y squared, then we multiply it by another y to make it y cubed, and then we multiply it by another one to make it y4, whereas y cubed would be y cubed, y6, y9, so on and so forth. The first term, or the first number of letters of the y's which are the same, y cubed here, so the lowest common multiple of the y's will be y cubed. Hence why our answer must be 8x squared y cubed. So, moving on to question 2. For which acute angle do sin x and cos x have the same value? Well, for these questions, sin x and cos x, we might need to think about memorization of the trig values. So sometimes you may have seen one of these tables before, sin x, cos x, tan x, and you need to remember each value. So when sin is 30, when sin is 45, when cos is 45, tan is 45, as well as the 60, as well as the 90, and you can either remember it really with a graph etched into your head, or you could memorize the table. Personally, I like to remember the triangles that you have. So you have the equilateral triangle, which is 2 by 2 by 2, to help you remember the 60 degree and the 30 degree angles. But for this one, I'm going to save a bit of time because the equilateral triangle does get shown later on. We'll look at which acute angle do sin x, cos x have the same value. So if we have a right angle triangle and we say, actually, let's make this an isosceles right angle triangle, and let's call these sides 1 and 1. If this is an isosceles triangle, we know that this angle here and this angle here are the same. Angles in a triangle are 180. As this is 90, these two angles have to be the same as it's isosceles. So we do 90 divided by 2 to give us 45 degrees. So I could draw 45 degrees here, but for the sake of clarity, I'll just leave it as that. 45 degrees is the angle here. So let's think about what we mean by sin x. Well, if you remember SOHCAHTOA, SOH is sin of opposite over hypotenuse, and cos is adjacent over hypotenuse. So if we think about sin and cos, for both of these will need the hypotenuse. We do not have the hypotenuse yet. If we're talking about any side here, or any angle, this side here is going to be the hypotenuse of our triangle. To work out the hypotenuse of the triangle, as it's a right angled triangle, we can use Pythagoras' theorem, a squared plus b squared equals c squared, remembering that c has to be the longest side, so c has to be this side here. A and b could be either one of these two sides, it doesn't matter. You're going to have 1 squared plus 1 squared to give you c squared. 1 squared is 1, 1 squared is 1, so add them together 2. 2 is c squared. And therefore, if we square root both sides, the square root of 2 is c. Yes, when you square root, you're going to have two values, positive and negative. However, as we are looking at a length, it can't be negative, so it must be positive square root of 2. So now we have the hypotenuse. SOHCAHTOA, so dealing with our SOH first, sin of our angle our angle is 45. So sin 45 is opposite over hypotenuse. Well, opposite this angle here, 45, is 1. And the hypotenuse is root 2. Cos 45 for our second one, adjacent. The adjacent side to this angle here is 1. And the hypotenuse is the square root of 2. So for a 45-degree angle, sin and cos of that angle are the same. So for which angle do sin x and cos x have the same value is 45 degrees. Another way of remembering, you might, and it would be good to remember your sine graph. So there's your sin x graph starting at 0, 0. And it might be good to remember your cos graph, which starts at 0, 1. At what we're saying here at 45 degrees, so if we were to go to 45 degrees here, they would have the same y value. They would have the same value, which is 1 over root 2. On your calculator, you might notice that when you type in sin 45, you actually get root 2 over 2. That is because if you rationalize the denominator, so if we simplify this by multiplying by root 2 on top and bottom, 1 times root 2 is root 2, root 2 times root 2 is 2. So you will see on your calculator it's actually already simplified it to root 2 over 2, but it is the same as 1 over root 2, it's just that the calculator has rationalized the denominator for us. Looking at question 3, the gradient of a straight line, 4y plus 3x minus 1 equals 0. To tackle this one, first of all, you need to know that you're talking about a single power of x with a single power of y, and we have told here that it is a straight line. So we know immediately it should be in the form y equals mx plus c. If I just do a quick review of what y equals mx plus c actually is, maybe that will help. If I make a nicer attempt, a nicer set of axes, that would help. So if we have, and I've just done a nice positive line here, so we have our line, which will be in the equation y equals mx plus c. When we say y equals mx plus c, it's important to know what our m part and what our c part are. Our c is the intercept. And the intercept is where our straight line, or for any other line, crosses the y-axis. This is the y-axis. So where it crosses the y-axis, that is the coordinate. So the y coordinate, because our x, if you think about it, x is this left or right. Well, if x is 0, then something times 0 is going to be 0, so we're left with y equals our intercept. So it is where it crosses the y-axis. M is the gradient. So alarm bells should be going straight away because we're talking about the gradient there. Gradient is the steepness of the line. So a higher value will mean it is more steep. Higher gradient, more steep. So we might have a curve with a straight line, sorry, which goes like that. It's going to have a much higher number than a gradient like that. So important to remember y equals mx plus c. We want to find out the intercept here, to find out the gradient, we want to get this equation into something that looks much more like y equals mx plus c, because in this form we can see straight away what the gradient is. To do that, we're going to have to say, okay, well, 4y plus 3x minus 1 equals 0. I'm going to have to rearrange this, so I end up with y equals and then my mx plus c. So first of all, we're going to rearrange this equation. How we're going to do that? Well, we want to get our minus 1, get rid of our minus 1, so we want to end up with y by itself. So how do we get rid of minus 1? We add 1. When we say get rid of, remember what I'm talking about here is making it equal to 0. If we have it equal to 0, then we don't bother writing it on this side. So minus 1 plus 1 will make 0, so our next line would be 4y plus 3x. Remember, these have nothing to do with the plus 1 because they have different endings, they have different terms. Only numbers and numbers can add or subtract together. 0 plus 1 is 1. Then we want to get our y's. Remember, we want to get y's on its own, so we need to get rid of plus 3x. So how do we get rid of plus 3x, i.e. turn it into 0? Well, we take away 3x. Just writing the steps down here and trying to keep equals in the straight line here. So 3x take away 3x is going to be 0, so we end up with 4y equals 1 minus 3x. Doesn't matter if I've written it as minus 3x plus 1. It just looks a lot nicer if I put my minus number after the positive number. Now, as we've got 4y, we want to end up with just 1y by itself. So we divide 4 by 4, because any number divided by itself makes 1. So we end up with 4 divided by 4, which gives us 1y. 1y, we say in maths, is just y. It's the same thing. We just oversimplify it really by calling it just y. And then we divide each of these terms by 4. Okay, yes, we're dividing both sides, but when we say that, we're actually dividing every term on both sides. So this is one term, second term, third term, separated by either the equal sign or a plus and minus. So we divide each term by 4. So this will end up being 1 divided by 4, which is a quarter, minus 3 over 4, x. Here, hopefully, you can see that this is our intercept, and this guy here is the coefficient of x, i.e. the number attached to my x, which is minus 3 quarters. And they've been quite sneaky in the multiple choice question by providing you with both minus 3 quarters and 3 quarters, just to check that you know what you're talking about in terms of our minuses and positives, just in case we made a mistake somewhere here by maybe adding 3x by mistake. If we didn't make that mistake, then we would have ended up getting minus 3 quarters, and therefore we can circle minus 3 quarters. That is our gradient. Moving on to question 4. We have the area of sector A ratio to area of sector B in the form 1 to 3, so it's in a ratio 1 to 3. The radius is 6 centimeters of our circle. We have 4 sections, 4 sectors as is shown. We know they're in the ratio 1 to 3. So as we have this part which will be 1 and this part which will be 3, remember a ratio is talking about a part dot dot part, so we're in part to part, as opposed to a fraction which is a part of a total. Okay, big common mistake is you forget that you're actually talking about a part to a part with ratio. So, working out the area of sector A. Sector A is going to be a part of the full area of the circle. So we need to work out the area of the circle before we work out the area of the sector. Now the area of this circle, you should remember the area of a circle formula is pi r squared. So pi times r, our radius, which is 6 squared, which will be 36 pi. Okay, that'll give you your first mark. Do our marks in blue. Our second mark, if we have 36 pi as our area, well, how much of this circle do we have? Well, vertically opposite angles are equal. So as we've got two straight lines that cross over at this point here, A is the same as C in terms of this angle here. So as a ratio, this would be 1 part, and this would be 3 parts as well. So in total, how many parts of the circle do we have? Well, if we add up the parts, 1, 3, 1, and 3, there are 8 parts to this circle. There are 8 parts to the circle. And if we want the area of sector A, then we will want one of those 8 parts. So we share 36 pi into 8 parts, bus stop division. How many 8s go into 3? 0, remainder 3. How many 8s go into 36? Will be 8, 6, so let's write it down here, 8, 16, 24, 32, 38. Remember, we can't go over our target number 36, so it's going to be 1, 2, 3, and 4. So it's going to be 4, remainder, we got to 32, we wanted to get to 36, so we needed 4 more. So it's 4 and 4/8. Okay, our remainder here will make up our numerator, and what we're dividing by our divisor will be our denominator. Okay, that's how we got that. You can simplify that. I mean, it is 4 and 4/8 pi. Don't forget that pi there. 4 and 4/8 pi. 4 over 8. I'm just showing you for completeness is a half. Divided by 2. Divided by 2. So divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So this will be 4.5, which is 4.5. So it's 4.5 pi. That is the area of that sector. Breakdown of the marks. We've given you the first one up there. For finding that it is 36 pi divided by 8 is your second mark, and your third mark is for either putting something like 4.5 pi or 4.5 pi. Give your answer in terms of pi. Very important to remember that if it asks for that, leave it in terms of pi. Don't try and work it out. Very painful if you haven't got a calculator when you see students trying to work out 4.5 times by 3.141592 and such so forth. So please don't do that. That's question 4. Question 5, looking at the table of information. The shortest time was 3 minutes and 40 seconds, so 2 marks here. If you know that the shortest time was 3 minutes and 40 seconds, the greatest possible range, well, the time could have been anywhere between, well, more than 0, but equal to 20. It could have been 20. It goes up to 20. So the greatest possible range of values will be 20, take away 3 minutes, 40 seconds. Okay, this will give you your first mark, showing that you know it's 3 minutes, 20 minutes, take away 3 minutes, 4 seconds will be your first mark. Your second mark is for actually working out what that is. Well, 20 take away 3 minutes, 40 seconds is going to give you 16 minutes and 20 seconds. You could check that because you know 20 seconds plus 40 seconds will give you 1 minute, 16 plus 3 is 19, plus 1 more is 20, so we ended up with 20. The inverse operation will give us confirmation. So that's our second mark. For 5 part B, how do we know that Jack is wrong? The median time is exactly 10 minutes. He must be wrong because median, remember, we're talking about the numbers if they were in order. Which number would be in the middle? Okay, so if they were in order, the number in the middle would be the median. In this example, the generic formula given is n plus 1 divided by 2, n plus 1 divided by 2. So however many there are in the data. So how many numbers are there in the data? 1, 2, 3, 4, 5, 6, 7. If there are 7, then this would be 7 plus 1, which is 8. 8 divided by 2, which is 4. So it would be the fourth. It would be the fourth number along. So this, in this case, it would be 1, 2, 3, 4. It would be 3. Okay. We know that he's wrong because if there are 100 people, then where is the 50th person? Remember, if these are in order, which they are, because we go from 0 to 20, where is the 50th person? Because wherever they are lies the median time. Well, it's a case of addition. 17 plus 28 will give us 35, 45. So the 45th person lies in this category here. Add 33, and that gives us 78. So the 78th person finishes off the 15th minute. So in this class here lie the 46th to the 78th person. If we're looking again for the 50th person, that means that they must lie in this category here, because the 45th person was here, and everyone after that, up to the 78th person, was in this category. Notice here that we are saying 10 is less than the time, which is less than or equal to 15. Therefore, it can't have been exactly 10 minutes. By definition, 10 is less than t, so it can't have been equal to t. Give a reason, you could say that. It's absolutely fine. That is where the 50th person lies. And then maybe not with the exclamation mark. But and that is question 5, part B. Question 6 is looking at a constructions question. Using a ruler and compasses, construct a triangle ABC such that B to C is perpendicular to AB and AC is 9 centimeters. So we know we're going to be 9 centimeters away from A, which implies some sort of arc at some point. But we do know that AB and BC are perpendicular. What this means is our line AB and the line BC, so C is going to be somewhere up here, it has to be perpendicular to this line here. So we need to bisect this straight line to make it a 90-degree angle. So what we do is we extend our line B, extend that line with a ruler a bit further. We put our compass point on B, and we can construct 2 arcs there, so equal distance apart. With the same distance there, we put our compass point now here and create an arc. We then put our compass point here and create another arc. Importantly, and obviously that's going to be a bit better of a construction line than I've just done there. Importantly, your compass point and the pencil, so the compass pencil here and the point here, they are always the same distance apart. So they're always the same distance apart for that line to make that arc, for this line to make this arc, and then from your compass point there to make that arc, and from your compass point here to make this arc. With this, you have now constructed a 90-degree angle from B up. So if you do a straight line through the crossover point here to the center here, that will be 90 degrees. I might be 1 degree off here, but it will be a 90-degree angle there. That is worth 2 marks. So constructing the perpendicular, first of all, 1 mark is for the arcs extended and intersecting here, and then the second mark for extending that line all the way out. Your final mark is for putting your compass point here, making with a ruler 9 centimeter distance between your point and your pencil, and we'll say that's over here. Wherever that is, you need to, with a ruler obviously, construct a straight line that goes all the way down to A. So with a ruler obviously that'll be dead straight, and you label that C. For that, it is your final mark. However, remember with constructions, we need to be able to see these construction lines. If we can't see these construction marks, you won't get any marks. So yes, you might have done a lovely 90-degree angle without any construction marks and a nice 9 centimeter line. You won't get any of the marks unless we can see these construction marks here. Equally, if you've just done that construction line and joined it there, as long as that is 9 centimeters, you will only get one of the marks. Okay, we need to be able to bisect this straight line to create a 90-degree angle for all 3 of those marks. Question 7 starts off with a bag containing 20 counters. 10 of them are red, 8 are blue, and 2 are yellow. So for this question here, we're talking about if all 3 of the colours, or of the counters, sorry, are of the same colour, what is the probability the next counter taken out is yellow? Bit of a nasty question, unless you've read it quite carefully. So we're looking at the next one being yellow. If they're all 3 are taken out being the same colour, they could have all been red. There are 10 there that are red, so they could have all been red, that's possible. There are 8 that are blue, so they could have all been the same colour, that's possible. However, they can't have all been yellow. If 3 were taken out being the same colour, then none of them could have been yellow. There aren't 3 yellows to take, so you have to have those 2 yellows still there. So what's the probability? Well, there are 2 yellows left, and if 3 of them have been taken out, if we started with 20, then there are 17 left. So it's 2 out of a total of 17 that are left. So the probability, 2 out of 17. Remember, you could have written it as a decimal or percentage, but that's going to make things far too hard. You might as well just leave it as a fraction, because that is a sufficient way of answering the question. 7b, if all 3 counters are different colours, what's the probability the next counter taken out is yellow? Okay, well, if they were all different colours, then that means, as there are red, blue and yellow, that there must have been one of each. There aren't any more colours that it could have been, so all 3 were different. It can't have been that there were 2 red and 1 blue, because they wouldn't be different colours. It must have been 1 red, 1 blue, 1 yellow, meaning that if we want to work out the probability of the next one being yellow, well, there is 1 yellow left, because we must have taken 1 out. And again, if we've taken out 3, that's going to be 20 take away 3 again, which is just 17. So 17 is our total. It's 1 out of 17. Okay, so looking at question 8 now, we've got an inequality question. We're looking at listing the integers that satisfy both the inequalities. 2x plus 7 is less than 0, and x is greater than minus 10. So when we're thinking about these inequalities, we'll treat them as if they were equalities. So we'll treat it, the first equation, if we're trying to solve it, to find out what x is, or in the inequalities terms, what the region for x must be. We have 2x plus 7, and we'll treat it as if it was equal to 0. Okay, we'll treat it as if it was an equality. The only difference is we've got this symbol here instead of the equality, but it behaves exactly the same. So we will treat it exactly the same. So if we have over here 2x plus 7 is less than 0, think about what we would have done if it was equal to 0, because we're used to dealing with that a little bit more. We've got to end up in a situation, remember, where we've got x equals, or in this case is some sort of inequality, and then 0, or a number. So first thing we're going to do is, if we have 2x plus 7 is less than 0, we're going to take away 7. We want to get, remember, we want to get our number with the letter by itself on one side, so we've got to get rid of this number here. So instead of plus 7, we do the opposite, so we want to turn it into 0, so we kind of don't see it anymore, we get rid of it. That's what we say, instead of turn it into 0, getting rid of it. 2x plus 7 minus 7 will leave you with just 2x. Inequality stays the same, as we haven't times by any negative numbers. So 0 minus 7 will just leave you with minus 7. Now if we have two lots of something and we want to have one lot of it, we will divide it by 2. 2x divided by 2 will leave you with 1x, which we'll just call x. 2 divided by 2 and 1. And then the inequality symbol stays the same. We've divided by 2 on both sides, so it's minus 7 over 2. Minus 7 over 2, if we wanted to check, minus 7 divided by 2 would be minus 3 remainder 1, which is minus 3 and a half, so minus 3.5. So we have this is the same as this, but leaving it in improper fraction form actually will be easier maybe when you move on to something like an A-level paper. This symbol might be a little bit easier, but for understanding it's important to know that these two are the same. So this is the mixed fraction version of improper fraction minus 7 over 2. If we have x is greater than minus 10, then we have to think about what this would be on a number line. If I quickly draw a number line here, so if I say that this is 0 and these are all positive numbers over here, and therefore these are all negative numbers over here, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus, if I extend it a little bit more, minus 10. I could fill in all these numbers, but for efficiency I won't. And remember, they would be getting smaller and smaller, these numbers over here, so it would be minus 11, so on and so forth. We want to know whereabouts our x must lie, and it must lie as it's greater than minus 10. It can't be equal to minus 10, so it's got to be greater than minus 10. But as we've solved the other inequality to get x being less than minus 7 over 2, or minus 3.5, 1, 2, 3, so this is minus 3 here. We know that it's got to be smaller than minus 3.5. So it's got to be somewhere in this blue region here. And we can define it by saying x is between the values, between these two values here. We've got minus 10 and minus 3.5. I could have written it as minus 7 over 2, that's absolutely fine, but I'll just keep it as we're talking about. We've got integers here. It might be nicer if we keep it as integers. Well, where is x going to lie? Well, we know that x is going to be greater than, not equal to and greater than, just greater than minus 10, but it's got to be less than minus 3.5. And therefore, this is explained through this singular inequalities. This the integers that satisfy both of these inequalities. It's got to be, therefore, minus 9, minus 8, minus 7, minus 6, minus 5, and minus 4. This is the list of integers that satisfy both of these inequalities. The inequality would be this, but the integers that satisfy both of these inequalities are the whole numbers. Remember, integers means whole numbers. So this is the list of whole numbers that are satisfied by this inequality here. Okay, so your answer, even though that inequality was lovely, only worth 1 mark, the answer is for listing these numbers here. Minus 9, minus 8, minus 7, minus 6, minus 5, minus 4. Okay, the inequality was there for purposeful reference. Moving on to question number 9, a directly proportional question. So we're not given much information here, but we are given that y is directly proportional to x. Therefore, we can say y is some function. We call it k when we're talking about direct proportion, but it could be any symbol, is directly proportional to x. So it's multiplied by something. There is a scalar here, scalar that we multiply x by to give us y. Y is directly proportional to x. That's what this means. So Fortunately, they've given us this here. And quite quickly, you might be able to tell that 63 is actually in these 7 times tables. So if we substitute our 63 instead of y, so 63 equals k, our scalar, our something, multiplied by x. Well, the x value for when y was 63 in this equation, the x value was 7. So it's k times 7. Let's do a dot, which means times. I try and do my x's like that if I'm talking about algebraic x's, but a dot may be more easy to understand at the moment. It just means times here. So k times 7. So something times 7 makes 63. Well, if we do the inverse of this operation, if the operation was times, we'll do the inverse of it. So we're going to do divide. So we'll divide by 7 on both sides. 63 divided by 7 will give us 9. If you really wanted to check that, remember your bus stop is very important. 7s and 6 is 0, remainder 6. And then I could do my 7 times tables, and eventually I would find that it would be 9. Okay. I put the 0 there. I know I've written 63 here. It does end up being 63 here, but we write the 0 there because place value can get missed. And if we didn't put that 0 there, there's a risk that we would put a 9, and then some students do freak out and then put a 0 here, so they put 90, even though inherently that is incorrect. 7 divided by 7 is 1. 1 lot of k, so we just call that k. So we've found the scalar. We've found the proportional, the number which makes x and y proportional. So y is whatever x is multiplied by 7, sorry, 9. Y is whatever x is multiplied by 9. We found that k is 9. So therefore, if we know that y is proportional to 7, done it again, y is proportional to 9 multiplied by whatever x is, so write that again with my dot, y is multiplied 9 multiplied by whatever x is, then I know that what is y when x, let's say, is 0? Well, 9 lots of 0 is going to be 0. So this passes through the origin, not null. If I look at my final one here, my final x value, to find out what y is for the last mark, y is proportional, y is directly proportional to x, and we know that the scalar now that we found is 9, so 9 multiplied by, in this case now, it's minus 8. So 9 times 8 we should know is 72. However, as this is 1 negative in the multiplication, the answer will become negative, so it's going to be minus 72. So our y is therefore minus 72. Okay, moving on to question 10. Complete the table of values for y equals x squared minus 2x. If I have x values and y values in this table, then it's quite nice. It's given us this already. Remember, if it was just saying complete a table of values or make a table of values for y equals x squared minus 2x, it's always a really good habit to draw out one of these tables of values and just pick a few of the simple numbers, usually 0, 1, 2. If you want to be brave and go for -1, then go for -1. But in this case, we've been given a list, given a table to complete, so we must complete this table. The first few have been given for us, which is great. So what we have to do here is substitute our x values into this equation. That will give us the y value. So these y values, remember, these will change for different values of x. So if I have my first one, which I'll deal with, will be -1, just because it's nice to deal from left to right. So I know y is, my x here, we replace -1, so it's going to be -1 squared. Take away 2 lots of -1. Okay, again, I'm doing a multiply now for this one instead of doing a dot. So 2 times minus 1. I put them into brackets just so that it is a little bit easier to understand what's going on, because there is a difference between minus 1 squared like this and minus 1 all squared like that. This means minus 1 times minus 1, minus 1 times 1, which would be minus 1, whereas if we actually square minus 1, it is minus 1 times minus 1, which would be plus 1. A negative times a negative is a positive, but if it's not in the brackets, a note for your calculator exam, that would end up being a negative number. If you just put minus 1 then squared like this in your calculator, you would find that you actually got minus 1. The calculator doesn't appreciate that. You're actually trying to say minus 1 times minus 1, like this. So y ends up being equal to 1 minus, and then 2 times minus 1 will be minus 2. So we end up with y equal to 1 minus minus 2, and this is the thing where minus and a minus, only when they're next to each other, make a positive. Okay, minus minus makes a plus, only when they're next to each other. So 1 minus minus 2 means 1 plus 2, which is 3. So we can put a 3 here. If we move on to number 2 with our x value and find out what the y value is. So our x value here is 2, y equals 2 squared, and it doesn't matter about the bracket now because I'm not dealing with a negative number. So 2 squared minus, but I will do a bracket here just so with the bib maths I don't get confused at all, because it's quite easy to understand that I'm going to have to do the brackets first here. So y equals minus 2 times 2, doesn't matter which order you do these in because they're separated by a negative, but to save confusion, let's do 2 times 2 first here, which is 4, and 2 squared, which remember 2 squared means 2 times 2, which is 4. So y equals 4, take away 4, which means that y equals 0. Okay, so we've got a curve here which will go through the origin, and then it again looks like a minimum point might be around the y being minus 1 and 1 for the x value, but we will need to work that out later on. The last value for which we need to find is when x is 3. So if x is 3, again we substitute into the same equation, 3 squared minus 2 times 3. So 3 squared, 3 times 3, which is 9, minus 2 times 3, which is 6, so y equals 3. So we have these values now, and that'll be for the 3 marks. Draw the graph of x squared minus 2x from the values minus 1 to 3. So basically we've just got to draw on these values onto this grid. Well, minus 1, 3, remember it's x first then y, so x value minus 1, y value is 3. So I could do a little dot across here. 0, 0 is the next coordinate, so we're talking about here. 1 and minus 1, so here. 2 and 0, looks like here. And 3, 3, so 3 along and 3 up, so there. So I'm going to attempt to draw this with a curve. Forgive me if it's not completely accurate. Okay, so we're going to be as accurate as we can. And it is important to show that you understand that the curve would carry on going. Okay, so it's always a good habit to get into to carry on your points. Don't just stop here and stop here. If you do a little kink here, as you're doing it with a pencil, it might be worth rubbing it out and then just making it a nice smooth curve that goes through all the points. Okay, because on the AQA exam now more than ever, they are very strict on making the accuracy of your curve really tight. So make sure that it is as accurate as you possibly can do. Finally, I'll move this guy to give you a little bit more ease in understanding where the answer is going to go here. write down the coordinates of the turning point of the graph. So the turning point is the point at which we were going down, and it just, without using the word turn, changes direction to, instead of going downwards, it suddenly starts going upwards. Well, what are the coordinates of that? Well, the coordinates of that, that's this point here. This point here, it went down and it went back up. Okay, we could check this. So it's going to be 1 minus 1. We could check this by completing the square. So if you were to complete the square, you would end up getting, remember it's in the form y equals x plus a over 2 squared plus b. So we half this value here, minus 2, so it would end up being y equals x minus 1 squared. And then how would we make this into x squared minus 2x? Well, if we squared this, it would be x squared minus 2x plus 1. But we want to make it equal to y equals x squared minus 2x. So we don't want this constant here, so we need to take away 1. So in complete the square form, it would be y equals x minus 1 all squared minus 1. So the coordinates here, remember it's going to be the positive, which would make, whatever would make this bracket equal to 0, and that would be 1. So x has got to be 1, and the y value would be the number that you have as a b in your complete the square form. Okay, so moving on to question 11. John is drawing a quadrilateral. The length of each side is 5.2 centimeters to 1 decimal place. Complete the error interval for the length of one side. So the error interval is a clue as to what section of the curriculum we might be talking about. Error intervals, we are talking about accuracy. So what could it have been between in terms of the bounds of accuracy? Well, if we know to 1 decimal place that each side length was 5.2 centimeters, and we'll just make a little note, we are talking about centimeters here. If we rounded a number to 1 decimal place, we're doing the opposite of rounding here. We're thinking backwards. Well, if we rounded a number to 1 decimal place to get 5.2 centimeters, what's the lowest number that could have been? Okay, so we're going to talk about lower bounds and upper bounds. So the error interval could have been between the lowest bound and the highest bound, the upper bound. Well, what number is the smallest number that if you rounded it to 1 decimal place would be 5.2, and it would be 5.15. 5.15. If we had 5.14, if we rounded that to 1 decimal place, it would have ended up being 5.1. And if we had 5.16, then yes, that would have rounded to make 5.2. However, there is a number which is smaller, so a lower bound there exists. The lowest bound would be 5.15. So we want the lower bound, which will be 5.15. With bounds, it doesn't work that you think, okay, then what is the highest number that would have rounded to 1 decimal place to make 5.2? That's where we're different. We're not dealing with a subject called rounding, we're dealing with a subject called bounds, and for bounds, you need to think, well, the distance I went from 5.15 to 5.2 is the same distance as I go above 5.2 to find my higher upper bound. So if I went from 5.15 to 5.2, I added 0.05, and notice with bounds we are always going to be talking about moving up in another decimal place or another significant figure with a 5 on the end. So we moved up 0.05, so we move again up 0.05, and our upper bound has to be 5.2 plus 0.05, so 5.25. So therefore, be careful because we're using this inequality symbol here. It has to be the length, it has to be between, so it has to be greater than the lowest bound 5.15 and the upper bound 5.25. So we found our upper bound and we found our lower bound. It usually is easiest if you start off by looking at the lower bound first. So complete the error interval for the perimeter. What we're going to have to do, if you're talking about a quadrilateral, so it has 4 sides, the length of each side has been rounded to 1 decimal place. So we're just going to draw any old quadrilateral here. I've attempted to draw a rectangle, but it doesn't matter. Effectively, these will be the same. Well, it could be the same depending on what kind of quadrilateral you're doing. Well, if every side is the same length, then it will be a square. If these two are different, then it will be opposite sides are different, then it will be possibly a rectangle or a rectangle of sorts. The error interval is talking about, well, if the perimeter, if we know that the perimeter is adding up all the sides around the outside, so 5.15 this could have been, that's the smallest it could have been. So it could have been that all 4 of these sides were 5.15. So we could have had 5.15, 5.15, 5.15, 5.15. That's the smallest bound, the lower bound for each of these sides. It could have been 5.15, 5.15, so it's 5.15 times 4. So the smallest it could have been is 5.15 multiplied by 4, which will give us 20.6. So it could have been, the smallest perimeter could have been 20.6, okay? We're saying that each side has been rounded to 1 decimal place, so the smallest that each side could have been is 5.15. The largest that each side could be, if we did another quadrilateral, and the largest it could have been, if we rounded it to 1 decimal place, the upper bound would be 5.25. Okay, we're talking about bounds here, not rounding. So 5.25 multiplied by 4 will be 21. So therefore, the error interval for the perimeter will be, it could have been 20.6. That's the smallest value, and the largest value it could have been is 21. It's the error interval for each length. As we're doing perimeter, they could have all been the same length as this quadrilateral, so we times that by 4. 4 because it's a quadrilateral, and we go for the extreme values, the lowest bound and the highest bound. So somewhere between these two values is where the perimeter of our quadrilateral must lie. Moving now on to question 12 and a little bit of algebra. So we've got 2w minus 3 all divided by 6 equals 4. First of all, so 6 marks on this question. So quite a lot of marks. If you're thinking about the whole paper, that's just under 10% if it's out of 80. So how we deal with a fraction, first, if we're dealing with the algebraic fraction, 2w minus 3 over 6 equals 4. First of all, we're going to multiply both sides by 6. Why are we going to do that? Well, we've got a fraction here, and generally it's easier to deal with algebraic expressions once they're out of fractions. So we need to unwrap that fraction. As this is 2w minus 3 all divided by 6, this counts all as one term, and this counts as another term. So we need to multiply every term, so both these two terms, by 6. If you have 2w minus 3 all over 6, it's going to behave just like if we had 3 over 6 and we times that by 6, well, 3 over 6 times by 6 would be 3. Okay, 3 over 6, if we want a confirmation, is a half, 0.5, and if we times that by 6, then we'll get 3. So with this logic, if you multiply any fraction by the bottom number, you're left with what you have on the top. On the most basic sense, this works with a half, because we know that if we multiply that by 2, 2 lots of 1/2 is a whole. Okay, so we're just expanding on this as our starting point. That's meant to be a rubber. The fraction, therefore, if we multiply it by 6, like we said before, we're left with what we have on the top. So we're left with 2w minus 3. So 2w minus 3 equals, and then 4 times 6, 24. Suddenly this is a lot easier, or looks a lot easier to deal with. We have our first mark for multiplying both sides by 6. Now, how we deal with this, we want to end up with a w equals something. So what's preventing us from doing something straight away is this minus 3 here. So we have 2w minus 3 equals 24. So to get rid of the minus 3, we do the opposite of it. So if it is minus 3, we will add 3. We want to turn it into 0. That way we get rid of it. So how do we turn minus 3 into 0? We add 3. 2w minus 3, then add 3, will leave us with 2w. 24 plus 3 is 27. 2 lots of something equals 27. So we half it. So divide by the number attached to the letter. 2 divided by 2 is 1. But we don't generally write that. We'll just leave it as a w. So w equals 27 over 2, which is 27 over 2, which we could rewrite if we wanted to. That would be enough for the marks, but we could write 27 divided by 2 is 1. How many 2's going to 7? 3, remainder 1. So it's 13 and a half, or 13.5. So we've got it in multiple different formats, but they all mean the same thing. So 13.5 is your answer, but you'll get the answer. You get the marks for that one on this question. Now, if we're looking at solving this inequality, like we said before, we're going to try and treat it as if it was an equal sign. And what would we have done if this was an equal sign? Well, you might be able to see that this is a quadratic, x squared, so we know that it's going to be a quadratic. If it's a positive x squared, it's going to have a parabola that looks something like that. Okay, whether or not it has roots isn't the issue at the moment. So what we're going to do first of all, solving a quadratic in this form might be a lot easier if we first of all divide by 4. So if we were to divide by 4 on both sides, remember we're dividing every term, and instead of this question where we had 2 terms, 1, 2, so this was all one term and that was all another term, we've actually got 3 terms. That this all counts underneath my dot, that all counts as one term, that counts as another term, and 0 will count as a term itself. So 4x squared divided by 4, 4 divided by 4 is 1, so we're going to have x squared. 25, or minus 25 divided by 4 will be, let's leave it as a fraction, minus 25 over 4. And that is less than 0 divided by 4, which will be 0. So what we might do now is try and factorize, or might be even easier if we just say, okay, well, if we know x squared minus 25 over 4 is less than 0, why don't we move our 25 over 4 to the other side? Because then if we square rooted both of these numbers, because you might notice that 25 and 4 are both square numbers, we'd actually be left with our answers. So if we say, okay, well, I'm going to add 25 over 4 to both sides. Why are we adding 25 over 4 to both sides? Again, because we want to move, or we want to get rid of this minus 25 over 4, so we have x. Remember, we want to end up with our letter on one side and number on the other side, so we have x squared by itself if we add the opposite of whatever this is. So we have x squared minus 25 over 4 plus 25 over 4 will leave us with x squared. and 0 plus 25 over 4 will just be 25 over 4. X squared is less than 25 over 4, so what we do now is we can square root both sides. So if we square root both sides, x squared, the square root of x squared is x, just like if we said the square root of 4 is 2, or plus or minus 2 really. The same logic if we have a number which if we squared and then square rooted, we're left with the root. So it's going to be x. Is less than 25 square rooted, which is 5, and 4 square rooted, which is 2. But as we've square rooted, remember it's got to be plus or minus 5 over 2. Okay, if we had 9 and we square rooted it, we could make 9 by plus or minus 3 squared. Minus 3 times minus 3 is 9, plus 3 times plus 3 is 9. So there are two solutions for this when you square root an x squared. So 5 over 2 is 2 remainder 1, which is 2 and 1 half. So 2 and a half. But remember it's plus or minus. So our answers are going to be that x is somewhere between minus 2.5 and positive 2.5. If you visualize it, what we're saying here, as this is a quadratic, if we visualize it with a diagram, we might want to say, well, 4x squared minus 25 is going to look like we said before, something like that. And we want to know where it is less than 0. So we want to know where on our inequality we are underneath x equal to 0. So we're less than, our x is less than 0. So we want to know where these points are here. And what we're doing here is saying, well, it is true for this graph when we are between the values of minus 2.5 and 2.5. So all of this that we've done here is... So question 12 part C is looking at solving 1 over y minus 6 equals 5. The first thing you should notice about this is that it's going to be algebra and it is in fraction form. So we've got to tackle this, I guess, algebraic fraction. And how we would do that is quite similar to, well, very similar to what we would do if they were numbers. So if we had fraction form of numbers, we want to get rid of the fraction part. We want to get rid of the bottom so that it's going to be a lot easier to tackle. So if we had, for example, 2 over 3, 1 over 2, and then let's extend that to an example with 5 over 11. So if I had a half, and I wanted to turn it into just the whole number part, what I would do is multiply it by, so do the inverse of divide by 2, which is times by 2. So if I half, I times by 2, and that would be 1. If I had 2/3, and I multiply it by 3, as this was divide by 3, I multiply by 3, and I'm left with 2. 2/3, 3 lots of 2/3 would give you 2. If I have 5 over 11, and I multiply by 11, I have 5. What we're doing here, to put it simply, is saying, alright, if I have a fraction and I multiply by whatever is on the bottom, I'm left with what I have on the top. The most simple example of this is a half times by 2, or half doubled is 1. But the idea extends to harder examples like 5 over 11 times by 11 to give you 5, and then further on to algebra. So if I had 2x over 7, if I multiply using this knowledge, if I multiply by 7, my answer is 2x. With that, we use a very similar but extended version of that to tackle this problem. If we have 1 over y minus 6 equals 5, what we would do is multiply, like we did before, multiply by what we have on the bottom, which is y minus 6, on both sides. And we'll be left with what we had on the top of the fraction. So 1 over y minus 6 multiplied by y minus 6 will leave us with 1. If we have 5 and we multiply it by y minus 6, we'll get this bracket which we need to expand. Okay, remember this is all one term, okay, even though we've got two separate parts underneath the fraction, so as a denominator, this will all act as one term. So when we multiply by y minus 6, we're not multiplying this and this separately by y minus 6. This is all one term. It's enclosed by one single division. So when we've got this, we expand the right-hand side. So 5 multiplied by y, 5y. 5 multiplied by minus 6, minus 30. So we want to end up, if we're solving, we want to end up like it implies down here. We want to end up with y equal to something. So if we want to get y equal to something, we need to get the term with y on its own on one side. So how we do that is we need to get rid of our minus 30, our number on the same side as the y term. So to get rid of it, remember we mean turn it into 0. So how we turn minus 30 into 0? We need to add 30. Minus 30 plus 30, 0. So we're left with, on this side, just 5y. 5y minus 30 plus 30, just 5y. 1 plus 30, 31. And now we're one step away. If we have 5y, 5 lots of y equals 31, we will divide by 5. Divide by the number attached to the letter, and so we'll leave it in fraction form. 31 over 5 equals 5 divided by 5, which is 1y, or just y. So your answer, y equals 31 over 5. This one here, it's 1. And our hypotenuse for this right angle triangle, remember the trigonometry only really works with SOHCAHTOA for our right angle triangles. So our hypotenuse is 2. So cos 60 has the value of 1/2. If you had a different question which was talking about maybe sine, so if I want to know maybe what sine 60 was, we would have to have worked out what the opposite is, and we could work that out through Pythagoras. Right angle triangle, we know that a squared plus b squared, which we don't know, equals c squared, the longest side, hypotenuse. So we know 1 squared plus b squared equals 2 squared. So 1 squared plus b squared equals 2 squared. 1 squared with 1 plus b squared, which we don't know yet, equals 2 squared, which is 4. Solving this equation, we would take away 1 to get rid of our 1 from this side. So minus 1 on both sides to give us 3. So b squared equals 3. And then we would square root both sides to give you b equals the square root of 3. I'd say plus or minus here, but as this is a length, it has to be positive, so it has to be positive root 3. Okay, in GCSE, we're not going to deal with negative square roots. So b is a square root of 3, so you would have to say opposite over hypotenuse for sin 60. Well, opposite is root 3, hypotenuse is 2, so it would be root 3 over 2. Okay, so that might be where some confusion might lie. If people have circled square root of 3 over 2, they might be thinking of their sin 60, which would be great knowledge, but unfortunately not very helpful for trying to work out cos 60. So in our triangle here, if we've got to work out, show that b equals 7, what we're going to use is going to be our cosine. So our cosine rule, we should remember, is it's chosen b here, but I'm just going to write it in the format that you might remember it as, which is a squared equals b squared plus c squared minus 2bc cos a. So we could rearrange this to make b squared on itself. So we could change these letters to maybe put b over here, which would be fine, because you could say b squared equals a squared plus c squared. But then you would have to, of course, remember that this letter would turn into an A, and the angle would be cos of B this time. So the angle opposite B. As long as you've got the angle opposite B in your cos A, you'll be all right. I personally would just prefer to do this and call that A. Okay, and then just remember at the end that actually we're talking about B equals 7. So when we found out what A is, we just change it to a B at the end. That way you need to really remember that formula and then plug it in. So labeling our sides and our angles, we've got A here, so I'm going to label the angle opposite A as capitalized A, and then it doesn't matter which one you call B or C. This side we could call B, but for argument's sake I'll just call it C, and this side I'll just call B. Then it's a case of, okay, well, A squared equals, I've called B this side here, so B squared, which we've called 8, so let's do 8 squared, plus C squared, which we've called 5 here, so 5 squared, minus, and then it might be easy if you think of it all in brackets, so you know to do all of this at once. So 2 lots of 2 times BC, so 2 times 8 times 5 times cos of 60. So A squared, if we just smarten this up a little bit, simplify it, 64 plus 25 minus 2 times 8, which is 16, 16 times 5, which is going to be 80, times by, and that's a bracket, times by 80, multiplied by cos 60. But we know cos 60 is a half. So therefore A squared equals 64 plus 25, which is going to be 89, minus 80 times a half. Remember, when you multiply it by a half, it's going to be 80 divided by 2 times by 1. So a whole number divided by the bottom times by the top, you might have heard. So 80 divided by 2, which is 40, 40 times by 1, which is 40. So it's going to be 40, or just half of 80 is 40. So A squared equals 89, jumping the gun a bit, 89 take away 40, which is 49. Therefore A is, if we square root of both sides, A is 7. It can't be minus 7 again because we're talking about a length, so we know that A is 7. We defined our B as A, so therefore we know B equals 7. Either way you do it, you end up with the side that you've determined as 7, and that will give you all the marks. Okay. Question 14. Okay, so with question 14, we're going to have to look at the cheapest way to buy 21 tins if we've got all this dog food. So lovely, I'd say real world scenario, but I don't really own a dog. So single tins at 80p each, buy 2, get 1 free. Cheapest way to buy 21 tins. Single tins 80p each, buy 2 and get 1 free. So therefore, if I pay for 2 of them, so if I have 80p and I buy 2 of them, so times by 2 for £1.60, I actually am paying for 3. So 3 tins in this scenario is costing me £1.60. Okay, yes, this is pounds on this side, but I'm just going to keep it as decimal. So 3, so tins 3 is £1.60. Again, I know I'm doing this on the computer and it comes up a lot bigger than the writing would have been in the exam, but it would be good if you've got all 3 of your decisions in separate columns. Just 1 for the examiner, and 2, I guess more importantly for you, because it keeps everything in one direction, so you can kind of see where you've ended up with your answers here, here, and here. So if I've got 3 tins for £1.60, the cheapest way to buy 21, well, if I'm trying to buy 21 tins, and I know 3 of them cost me £1.60, 7 times 3 or 3 times 7 is going to be 21. So if I multiply £1.60 by 7, 7 times 1 is going to be 7, so 60p times 7 is going to be £4.20, so it's going to cost me, oh my goodness. Okay, looking at question 14, and we've got a comparison of Best Buy problem. This isn't a standard GCSE Best Buy problem where you have to say, okay, which one is the cheapest. What we're actually looking for this time is the cheapest way of combining our offers to give us 21 tins. That might be the first thing that you want to notice. AQA is trying to make it a bit more lifelike by selling you tins of dog food and not saying, okay, which one's the cheapest. You're actually saying which way is the cheapest to buy 21 tins. So offer number 1, 2, and 3. The first mark is awarded for just being able to compare the cost of the same amount for 2 of these combinations, and the second mark will be for being able to compare all 3 of them. So we've got an offer here which is 80p each, and if we buy 2 for £1.60, we actually get 1 more for free. So we get 1 more for free, and so we can get 3 tins from the first offer for £1.60. If we compare that to our second offer, so this is offer number 1, our offer number 2, we're going to buy packs of 6. So straight away, we're actually going to need to say how much does it cost for a pack of 6. And it tells you that for 6 tins, it's going to be, for offer number 2, it's going to cost you £3.50. Offer number 1, if we wanted 6 tins, well, we know 3 tins is £1.60 for offer number 1. So therefore, if we double that, we get 6 tins, 3 tins times 2 is 6 tins, £1.60 times 2, £3.20. So we can say, actually, our first mark can be awarded for showing that a comparison, 6 tins, £3.20 versus £3.50. Offer number 3 only kicks in when you want to buy more than 6 because it only gets sold in packs of 12. So for our second mark, let's compare all 3 offers. So I'll squeeze in number 3 at the top here. Number 3, packs of 12, £5.50 per pack. Okay, cool. Is that going to be the cheapest way of buying 12? Well, offer number 2, which if we know 6 tins cost us £3.50, a big mistake that people might make is saying, okay, well, 12 tins is going to cost you £7, because if I double that, I get 6 times 2, which is 12 tins, £3.50, which is doubled to make 7. However, the offer for 2 packs is £5. Therefore, for 2 lots of 6, which is 12 tins, £5. Number 1 carries on as the same offer, so we can just double £3.20 to make it £6.40. So clearly here, the cheapest way of getting 12 tins, is using offer number 2, which costs us £5. So if we think about our real scenario that we have, 21 tins, and we've now bought 12 of them, so we need 9 left. So we need 9 left to buy, which actually rules out offer number 3 because it is only sold in packs of 12. So we can't buy another one of those. So offer number 3, you are the red herring here. You are completely irrelevant. Offer number 2 versus offer number 1. How would we buy 9 more? Well, if we compare our 6 tins here, as the 12 tins now is irrelevant, all this stuff now is irrelevant. it's actually cheaper to buy 2 single tins and get one for free. So £3.20 offer number 1 is the cheapest way of getting 6 tins. So therefore, we have 6 tins, which if I just highlight here, 6 tins, the cheapest way will be offer number 1, £3.20. So once we've bought 12 tins, and then we've chosen actually, well, we can get 6 more tins for £3.20, we now have, so minus 6 to this, and we need 3 more tins. So 3 left. So we've chosen this one, and we've chosen this offer, so £5 and £3.20. Well, we need 3 more tins. As offer number 2 is sold in packs of 6, it now becomes irrelevant. We can only use offer 1, single tins, buy 2 will get 1 3. Well, 3 tins for £1.60. We're going to use that offer, so we're going to use this offer that I've ticked, this offer that I've ticked, this offer that I've ticked. That gives us 12 plus 6, 18 plus 3, which is 21. Therefore, 12 tins, £5. 6 tins, £3.20. 3 tins, £1.60. And how much are we spending? Well, a little bit of addition, and it's £9.80. £9. So forget the pound sign, £9.80. That is an attempt at a 0. £9.80. That's the cheapest way of buying 21 tins. 1 mark was for comparing 2 of the 3 offers. The second mark was comparing all 3 of them. The third mark was for just working out any way of buying 12 tins. And the fourth mark was for the correct combination, which was the 12 tins, the cheapest way of buying 12 tins, the cheapest way of buying 6 tins, and then the cheapest way, or only way in this case, of buying 3 tins. Moving on now to question number 15. 60 people take part in a quiz. The graph summarizes their scores. And if we think about what we're looking at here for a second, cumulative frequency graph, estimate what fraction of 60 people scored more than 30. So to estimate on a cumulative frequency graph, we're going to have to remember that we have to draw a line up from or across from one of our axes to hit our line, and then go either across or down and say, okay, well, what's the quantity at that point? Well, in this case, in this scenario, we're talking about what fraction of 60 people scored more than 30. So our score is where we start. So our score, if we go using a ruler directly up from there, and if we go then from there directly across, we're going to have to say how many people is this, and it looks like here 16. So 16 people scored 30. So what fraction of people scored more than 30? And your first mark here out of your 2 is for doing that line and reading off at 30. So 30 the score, and then doing that line across. If you put 15 or 16, you would have got that mark. But the second mark for working out the fraction. So there were 60 people overall. That's what cumulative frequency is. It's the sum of all the people or the quantity of whatever it is that took part. So 60 overall. However, we want to know how many scored more than. So it's going to be all these marks up here, more than 30. So 60 minus our 16 will leave us with the number of people that took part in the quiz that scored more than 30. Well, 60 minus 16 is going to give us 44. So it's going to be 44 out of the total of 60, which is enough for the mark. It doesn't say that it wants us to simplify it. So 44 out of 60 is enough. However, because we like being really accurate, We might want to simplify that down a little bit. If they're both even numbers, remember we can just divide the top and bottom by 2 to make it equivalent. And this is 22 over 30, which we can simplify again, dividing by 2 to give us 11 over 15. Any one of these two would have given us the mark. You could have said, right, actually I know these are both in the 4 times table, so divided by 4 straight away, but for completeness I've showed you that there is another way of doing it. If you want to do it step by step, divide by 2 and divide by 2 again. So 11 over 15 or 44 over 60 would have given you the mark there. Estimate the median score. Well, for the median score, we have to understand what we mean by median, one of our averages. The median is when I have all my numbers in a list, so it could be a list like this, and it is the number in the middle. So if I have 1, 2, 3, 4, 5, 6, the generic formula is going to be n plus 1 over 2, which gives us the place of the median. If there is 6 overall, n is 6. So 1, 2, 3, 4, 5, 6, there are 6 numbers overall, so n is 6. So 6 plus 1 is 7, 7 over 2 is 3.5. So somewhere between the third and the fourth. 1, 2, 3. So it would be 2.5 here. However, that's the median. If we're looking at the graph, the median score would be if I had all these people, and they are in a list. They're in from smallest to largest. They're from smallest number score to largest score. They started, the first person looked like they scored around about the 10 mark, but the 30th person, which is important because we're working out the person in the middle. If there were 60 overall, there were 60 people that took the quiz, we need to say, well, okay, how much did the 30th person get? So how many points? And this isn't the best straight line, but obviously with your GCSE you'd be as accurate as possible. Looks like about 70. So 70 is the median. Remember, these are in order from smallest to largest, from lowest score to highest score. So if there is 60, you want the one in the middle. So half 60 gives you 30. Go across, go down, read off that score. That's the median score. You would have got the mark if you said 69 or anywhere between 69 and 70. Even though the score, you might have got half marks, don't know that, but you would have been awarded the mark if you put it anywhere between 69 and 70. If you wanted the interquartile range, which it hasn't asked for yet, we'll deal with that in just a sec. You will do something else. So, looking at, if I remember that score as 70, looking at question 15C, this quiz was easier than the first quiz because the graph is higher. It is a very generic statement and immediately makes me think this is going to be a bit hard to justify. So does his graph support his statement? The first quiz, so quiz number 1, is higher, therefore it was easier. I mean, I know what he means because these values have shifted to the right, and therefore, you know, the range is actually wider, but it starts off higher. I mean, shifted to the right in terms of height, and the y value is actually quiz 2 got higher. So it's a very vague statement. What we might say for the marks is actually let's compare where their medians would be. So if we had 60 in both, we're looking at the 30th value. So the 30th, that would be a way of comparing these scores. Well, the 30th, do a line across there. The 30th would be here. I'll just make a little note that it would be there for quiz 1. And then I could carry on because they both had 60 people take part. So I might carry that one on and obviously make this as accurate as possible, not a lot more accurate than mine. There, and then going straight down, and then going back to this point here, and going, okay, actually, I can go straight down and read off those values. So the median is actually, for quiz 2, median is 19 and the median is 70. Does that help us? Well, the quiz is easy because does this graph support the statement? No, because being higher actually doesn't mean anything about it being easier. The median, which I've now put it with a H, the median is one way of comparing, and actually the median for quiz 2 was, quiz 1 was higher. So the median was 70. The median for the first quiz was 19. Therefore, you actually say that quiz 1 was easier. So this is not supported by it. It's also, it will make you suspicious because that's a very vague statement. What you could also say for one of the marks is no. So this is out of 2 marks. So one of the marks would be no, but then also giving a partial reason. So for example, if you say no one scored less than 10, that would be a partial reason for quiz 1 being maybe easier. However, he's trying to say, first of all, that quiz 1 was actually easier because it's higher. So, that's one reason why he's wrong, because a few people scored in quiz 2, a few people scored less than 10, but more of them scored, no one scored less than 10 on quiz 1. You could also talk about the range being lower on quiz 2, but that wouldn't actually really give you any marks because we're talking about the ease. So which one is easier, which one was harder, and the range would be a good comparison for the spread of data, but it wouldn't actually tell you anything about how easy it was. Well, nothing really very informative on how easy it was. So those are the 2 marks, no, and then some sort of comparison. Talking about the medians might be the easiest way, and or talking about no one scoring higher than 77 on quiz 2, but the maximum score on quiz 1 being 98. So, question 16, and we're looking at bricks, which are red, yellow bricks, and ratios. So we've got another ratio problem, which is going to be heavy in your GCSE now. A toy box contains red, yellow, blue, and green bricks. So it's given us 4 colours, but a ratio with only 3 parts. 25% of the bricks are red. So 1/4, straight away I'm thinking 1/4 of the bricks are red. There are 12 yellow bricks. The ratio of yellow to blue to green is 2 to 3 to 1. So finally we have something which is very useful here. If we know that there are yellow, blue, green is in the ratio, so yellow dot dot blue dot dot green, and we know that it's in the ratio 2 to 3 to 1. So these are our parts here for our ratio. The yellow has 2 parts, but there are 12 yellow bricks. So yellow has 2 parts, and there are 12 bricks. Well, if we find out how many bricks are in 1 part, so 1 part equals what? So 2 parts is 12, 2 parts is 12, so 1 part, if we half it, will be 6. So 1 part is 6, and that is really important. Once we know what 1 part is worth, we can actually say, well, if B is given 3 of these parts, that's going to be 3 times 6, 18. Green is going to be given 1 of these parts, so as we worked it out, that's 6. 25% of the bricks are red. We know that there are yellow, 12, 18 blue, and 6 green. So if we add all these up, 12 plus 18 will give us 30, plus the 6 will give us 36. So we know that there are 36 bricks that are yellow, blue, and green. If 25% of the bricks are red, so if 25% are red, then that means that 75% are the rest. And if we know that the rest of them make up 36, because we just worked that out. So 36 is 75%. So 75% of the bricks is 36. Well, if we want to work out what 25% is, 75, if we divide that by 3, that'll give us 2, remainder 1, 3 is going to 15, 5, that'll give us 25. So 25% is 75% divided by 3. Therefore, if we divide 36 by 3, 12 equals 25%. Okay, we've done 75%, we divided by 3 to show that that was 25%. We've then done 36 divided by 3 to give us 12. So therefore, we know that if 25% of the bricks are red, as we were told up here, then get rid of some of this. If we know 25% of the bricks are red, and we know that 25 is 12, then there are 12 red bricks. So if there are 12 red bricks, and 36 of every other colour, then 25% plus 75% is 100%. So all of them, i.e. 100%, will be 12 plus 36, which is 48. And there's your marks. There's a few methods working out the one part. To work out on the mark scheme to get all 4 of the marks. One of those marks is for working out that one part is worth 6 bricks. Working out that there are 36 overall of the rest of the parts will give you, so 36 if you added up yellow, blue and green, that's the second mark. The third mark was for working out that 12 bricks was for the red, so this was the red guy. Yeah. So that was for the third mark. Let's just link them together. And then finally, the last mark was for the answer. 1, 2, 3, 4. Looking at question 17, A, B, and C. 8 to the power of negative 2. So as immediately when we're thinking about, and I'm going to do this in green for red for consistency. If we're thinking about our negative indices, we should be thinking, okay, well, a negative power should tell me that actually I'm going to have a fraction here. Okay, so a negative power usually means start thinking about fractions. To the power of minus something means it's going to be in fraction form, and the symbol that the power up here tells me what I raise my denominator to. So in this case it's a 1, so it's going to be 1 over 8 to the power of 1. If this was 8 to the power of minus 2, then this would be, again, first of all, the negative power means 1 over 8. But this time I'm raising it to the power of 2 instead of here where I raised it to the power of 1 because the power was 1 here. I'm going to raise it to the power of 2 because it's a minus 2. So 1 over 8 to the power of 2. Well, 8 to the power of 2 is 64, 8 times 8. So therefore it's going to be 1 over 64. If we're then solving, 4 to the power of x equals 8 to the power of 2/3. Where students might find this a little bit hard is they're thinking, hang on a minute, is x 2/3? Hang on a minute, it can't be 2/3 because these integers, these whole numbers here aren't the same. So what am I going to do here? Well, thinking about what you can find, and you can find 8 to the power of 2/3, fractional indices, 8 to the power of 2/3, if I had 8 to the power of 1/3, 8 to the power of 1/3, the denominator in your power is telling you what power to root it to. So if it's a 3 at the bottom, then we're actually finding the cubed root of our whole number. So this would be the cubed root of 8, which is 2. 2 times 2 times 2 makes 8, so the cubed root of 8 is 2. But we have to remember, actually, we've got to square it. The numerator in your fractional indices will tell you what to raise the number to the power of. So if we've got a power of 2 here, there's 8 to the power of 2/3, we find the cube root because of the denominator being 3. And then we'll square it once we've found that because the numerator is 2. So we do 2 squared, which is 4. So therefore, 8 to the power of 2/3 is the same as saying 4. And 4, remember, is the same as 4 to the power of 1. Any whole number really is actually just itself to the power of 1. So if we have 4 to the power of 1, which is 2/3, then what is actually 4 to the power of x? Well, you can compare them now. 4 to the power of x is 4 to the power of 1, so therefore x is 1. 4 to the power of x is, this is the same as saying 4 to the power of 1, so x is 1. And for question 17's part C, now we're looking at the square root of 3 to the power of 0 times, open brackets, 3 to the power of 1 plus 3 squared. So if we're thinking about what to deal with first, we might want to resort to our BIDMAS for a little bit of help. BIDMAS would tell me that I need to perform the operations inside the brackets first. 3 to the power of 1 is 3. 3 to the power of 2 is 3 squared, so 3 times 3. So this ends up being 3 to the power of 0, so the square root of 3 to the power of 0 times 3 to the power of 1 plus 3 to the power of 2. Well, if you know that 3 to the power of 2 is 9, 3 times 3, and 3 to the power of 1 is 3, then it's 3 plus 9, which is 12. So this ends up being 3 to the power of 0 multiplied by 12. The pattern with powers you might remember is if I have 3 to the power of 1, it's 3. If I have 3 to the power of 2, that's 3 times 3. And each time I raise one more power, I'm actually multiplying by another 3. So this was 3, this was 9, this is going to be 27. 3 times 3 times 3 is going to be 27. To work backwards, though, which might be helpful to remember to work out what 3 to the power of 0 is, well, 3 cubed is 27, 3 squared is 9, 3 to the power of 1 is 3. To go up each time, I'm doing the opposite of what I'm doing to go down each time, and to go down each time, I'm multiplying by 3, so I've got to divide by 3 to go up. Divide by 3, divide by 3, divide by 3. So therefore, 3 to the power of 0 is whatever 3 divided by 3 is. And as we've mentioned a few times already, any number divided by itself, is 1. 3 divided by 3 is 1. So this is the square root of 1 times 12, which is the square root of 12. If we get rid of this guy here, a bit of it anyway, give your answer in the form a root 3. So a constant, a number, then square root of 3. So this is going to require some surd knowledge. If I have the square root of 12, and I'll focus on that now, so the square root of 12, we should remember that the square root of 12 can be written as the square root of two numbers multiplied together. So the square root of 12 could be the square root of 6 times the square root of 2. That's true. Just like 6 times 2 is 12, the square root of 6 times the square root of 2 is going to be the square root of 12. So let's get rid of my doc. That's good knowledge, but not relevant knowledge for if we're trying to find out a root 3. This means that we've got a number multiplied by the square root of 3. Therefore, we've got to find a number which, if we square rooted, would end up being an integer, a whole number, which would then go with my square root. Well, the square root of 4 times the square root of 3 is another way of combining surds to make square root of 12. And the square root of 4, if we work up, is 2. So this is 2 times root 3, which we would put next to each other, just like algebra. If we had 2 times x, we would actually call it 2x. Surds behave the same way. 2 times root 3 would just be 2 root 3. And that is the same thing as the square root of 12. So, to answer the question, what is it in the form a root 3? Well, 2 root 3. Therefore, a is 2. root of 12 is 2 root 3, therefore A is 2. For completeness, the breakdown of the marks for the part A, only 1 mark, so you had to circle the right answer. For part B, it was 1 mark for either finding the 2 squared to give you, if you just wrote 2 squared, you would have got 1 of the marks, or if you wrote 64 to the power of a third, so worked out that the cube root of 64 is 4, so you could have done the reverse, so that would have been 8 squared to give you 64, and then the cube root of that. If you did this example, then working out that the cube root of 8 was actually 2, that would have given you 1 mark, and then cubing that, or sorry, squaring that, because the numerator was 2, squaring that to give you 4 would have given you second mark, so that's 1 mark for finding 2, second mark for finding 4, and the third mark was for the answer, 1. You could have done it a different way. You could have done 8 squared to give you 64, so if you wrote 64, that would have been 1 mark, and then if you cube root that, so as the denominator is 3, cube root that to give you 4, cube root that to give you 4, that would have been the second mark, and third mark was always for finding 1. For part C, if you said actually 3 to the power of 0 is 1, that's 1 mark. If you found that actually that multiplied by this expression gave you root 12, so if anywhere you put root 12, that would have been your second mark, and your final mark was for writing 2 root 3 or writing A equals 2. Okay, so either one of these two would have given you the marks. Looking at question 18, estimate on the velocity time graph of the car, estimate the distance travelled in the first 10 seconds. So if you remember that the distance travelled in a velocity time graph will be represented by the area underneath the graph, then you can say actually for 10 seconds, so after 10 seconds, where are we at? Well, if I try and do as straight a line as possible up here, so straight line up to there, we want the area of this section here, area of all of that. If you're trying to estimate it, it doesn't need to be exact, and if you go on to A-level maths, then you will actually find as close an estimate as we can find here, because we are talking about a curve. But for GCSE, you might want to visualize this as a triangle. So we've got a right angle triangle here. So we're finding the area of our right angle triangle. Not going into as much detail as, attempt at a triangle there. Not going into as much detail as the sine rule. You will just need to be able to remember, that it is base times by height and then divided by 2. However you want to remember it. Some people remember it as half base times height, but it's the same thing as base times height divided by 2. I prefer to use that because, well, it gives you a simple multiplication usually, and then dividing it by 2. There are sometimes advantageous ways of doing this because you might have a hard base to multiply by a height, so you'd be making the base smaller before you make it bigger, which might make the numbers easier, but knowing that there is more than one way of doing it will be useful. So base times height divided by, so if we work out the area of the triangle that we can kind of see that we've kind of made here, it is an estimate, so it doesn't have to be exact. If we work out the area of that triangle, that should be enough to give us a good estimate of the distance travelled in the first 10 seconds. So the area of a triangle is the base times the height, like we said before. So the base here, we could use 10, as it's the first 10 seconds between 0 and 10, and then we multiply that by the height, and the height looks like here, it is at 45. So this point here looks like a 45, so 45, and as we're quite late on in the questions, 18, you do need to be as exact as possible, so read across that it is actually 45. And then whatever that is, we divide it by 2. Well, 45 times by 10 is going to be 450, 450 if we divide that by 2. If we, as for we don't have a calculator, if you really want confirmation of that, bus stop, 45 divided by 2, 2, how many 2's going to 5? 2, remainder 1, how many 2's going to 10? 5. So your answer here, 225. 225, and it's given us meters, so we don't even need to worry about that. So 225. That is all 2 marks. One of the marks was for having maybe half times base times height, and then substituting in sensible values for your base and your height. So obviously the only sensible option for the base would be 10, and the height here 45. But as the mark is going to be somewhere between, if you've got a number between 225. Okay, looking at question 19, and we are looking at a problem with a triangle and a trapezium, and we're talking about the area of each of them being equal. So this question combines a few different things, as a lot of them in the new syllabus do, a lot of different topics mixed into one. So first of all, we're looking at area, so we might want to think about the formulae that we have for the area of a triangle, and we have a couple in the higher tier. We might want to think about maybe this is something to do with base times height divided by 2, and there is also another formula for the area of a triangle, so we think about our triangle areas. So we either have triangle areas base times height divided by 2, or we have half AB sin C. So if we have 2 sides and the angle in between them, we can actually work out the area of a triangle. Looking at this being near the end of the paper, we might start thinking actually it's probably going to be one of the harder ones of the two to work out. So area of a triangle we learn in primary school, really, base times height divided by 2, but only really when we get to year 10 or 11 do we start looking at triangle areas with half A, B, C, and C. So it's more likely to be something like that. Looking at the trapezium area, we should remember, because in the AQA papers, trapezium area is tested regularly. Half, open brackets, A plus B multiplied by height. That is the trapezium area, so trap area. What this means is half of the sum of the parallel sides. So the parallel sides here are 4x and 10x. If we add them together, half it and times it by height, the height being the distance between them. So it could be a trapezium like this. Remember, trapezium is a trapezium if it's got one pair of parallel sides. We're told it's a trapezium, so we know it must have a pair of parallel sides. Although it's not drawn accurately, we should be able to tell there that if it's a trapezium, it's clearly going to be these 2 sides which are parallel. So we can start off this question. If we're looking for giving your answer in the form y equals a over b multiplied by x, where a and b are integers, we want an expression for y. Well, where we start, you could start on this, you could start on this, but at some point we're going to have to, as they're equal, the areas are equal, we get some expression for the area of the trapezium, we get some expression for the area of a triangle, and then we're told they're equal, so make them equal to each other. We'll start off with the trapezium area. So a half of the parallel sides, so 4x plus 10x, multiplied by the height, so the distance between them, 3x. If we simplify some of this, don't try and expand these brackets yet. It's a lot easier if you just simplify what's inside the brackets, because algebraically you can do 4x plus 10x because they have the same endings, i.e. they both end in just a singular power of x. So it's half, 4x plus 10x is 14x, and then multiply that by 3x. Well, if we half 4x, we're going to have 7x, and we multiply that by 3x. 7x times 3x, 21x squared. So the area of our trapezium can be simplified down to 21x squared. And that is your first mark. Ignore that line. That is your first mark, 21x squared. Your second mark, well, you're going to have to use half a, b, c, and c. The hint is that, one, you don't have the perpendicular base and height, so you don't have the height being perpendicular to the base, so you would need that straight line up there. So we know we're not going to use base times height divided by 2, we're actually going to use half a, b, c, and c. We also have these two sides and the angle in between them. So we can do a half multiplied by 6x multiplied by 8y, so we could do a dot to signify that, multiplied by sine c, sine of that angle. Well, we're told sine of that angle is a third, so actually multiplying that by a third. If you just wrote that, that is worth 1 mark. But to get any of the further marks, you're actually going to need to work out what this is. So let's deal with this maybe by doing a half times by 6x, half 6x, 3x, and 8y multiplied by a third, 8 over 3y. So 8 over 3y. So we have 3x multiplied by 8 over 3y, 3 divided by 3, so we're multiplying these together, but it's going to be, well, if you want to deal with the numerators first in the standard way, then maybe we could do 3 times 8, which is 24, all over 3. So 3 times 8 over 3, so 3 times 8 is 24, 24 over 3, xy. Okay, when you multiply letters, remember you put them next to each other. Well, 24 over 3 can be simplified to make 8. 24 divided by 3 is 8, so it's 8xy. So we have an expression now for the area of the triangle, and we have an expression for the area of the trapezium. Okay, so like I said, the mark could be awarded up here, but you will need these follow-on points to get to 8xy, which is going to be useful for working out the answer in the form y equals a over bx. So if we now think about the triangle and the trapezium areas being equal, well, if they're equal, we can set them equal to each other, just like we said earlier. I'm going to make this a little bit more thin. So we have 8xy, which is our area of a triangle, and our 21x squared, which is our area of the trapezium, and we set them equal to each other because we know the areas are equal. So the area of one is equal to the area of the other. What are we going to do here? Well, we know that we want to end up in the form y equals something, so we want y to be the subject of the equation. So how, if we've only got one y here, and we've got no y's on this side, we want to get y by itself on that side. So what we're going to do is divide by the expression that's with it. So the coefficient of y will be 8x. So we divide by 8x on both sides. 8x divided by 8x, as we've said before, anything divided by itself, so 8x divided by 8x is just going to leave 1, or in this case 1y. 21x squared divided by 8x. We can simplify this and then we've got our answer. So 21 over 8, as 8 doesn't go into 21, 21's not in the 8 times tables, we can leave it as 21 over 8. Remember, we want our answer as a and b as integers. Well, these are integers, they're whole numbers. So we've got x squared over x, and if you remember your indices rules, x squared over x is x to the power of 2 divided by x to the power of 1. So 2 minus 1 equals x to the power of 1, or just x. So our answer, y equals 21 over 8x, and so our integer a is 21, our integer b is 8, and that is going to be the solution but your marks are given, if I do it in blue, by setting them equal to each other, so appreciating that the triangle and trapezium area are equal, so setting them equal to each other like that gives you the third mark, and finding that the solution is y equals 21 over 8x is the final mark. You don't have to, for this question, say a is 21 or b is 8, but it might be good practice just to make sure that you're emphasizing that you know exactly what you're talking about to the examiner. So, looking at question 19, and we're facing a probability question. We haven't seen many of these so far in this paper, given probability's been given quite a big percentage of the GCSE now. That's quite surprising. 2 cards are picked at random. Work out the probability that both cards are B. Well, the probability from the first pick, so when you do the first pick, it could either be A, B, or C. And the probability of it being B, is the number of B's that there are, so 2 out of the total number of cards that there are, which it didn't need to do that because it tells us up here it's 6. So 2 out of 6, which is 1/3. So that's your first mark out of 3. The second time, though, so 2 cards are picked at random, the first card is not replaced, so the probability of both of them being B. Well, if you've picked the first card and it was a B, and that was a 2 in 6 chance because there were 2 out of 6, let's scratch one of them because one of them's been taken. So the second time you pick, if it's not replaced, that means that there are only 5 left. So the probability is out of 5. How many Bs are left? Well, there's 1 B left because the first one picked was a B, so it's a 1/5. So the probability of both of them being picked is 1/3 multiplied by 1/5, and if you write that down, you get your second mark. And if you work out that 1 times 1 is 1 and 3 times 5 is 15, that is your third mark. So a third or 2/6 gives you 1 mark. Writing down a third times a fifth gives you the second, and the answer gives you the third. Usually you see these as a probability tree, but because we've got 3 options, there would end up being another 3 outcomes coming off from each of these stems, so it would end up looking something like this. Keeping it simple, you might want to see it as just one choice, so one decision being made is that it was 2/6, and then the second choice was when there was 1 less, so it was out of 5, and then the first one was blue, so it's 1/5, multiply them together. Remember, moving down the probability tree, you have to multiply the probabilities. Looking at, so keep that there, looking at the second part of this question, so B, the first card was replaced. So someone's cheating here. The first card was replaced. How does this affect the answer to part A? Well, if it was replaced, then instead of getting rid of on our second choice, so our first choice will stay as when we selected B, there was a 1 in 3 chance. It was a 1 in 3 chance when we first selected B. So it's the first time. And the second time we pick it, if we've chosen it and then we put it back, then we still have all 6 cards there. So it was replaced. So we took it, we put it back, there's still 6 cards there. So again, it's going to be 2 out of 6, which simplifies to a third. So the second time round, there's a 1 in 3 chance of picking a blue again. 1 times 1 is 1, 3 times 3 is 9. So there's a 1 in 9 chance. Is the probability bigger or smaller? Well, 1/9 is bigger than 1/15. So there is a larger chance, there is a higher probability of picking B's both times round if you have replaced the card. So 1 mark for this one, it was quite generous. 1 mark was given for just ticking. Probability is now bigger. The second mark was given for a valid working or statement to support the answer. So something like 1/3 is greater than a fifth, or if you've done what we've done here, which is work out that the probability is actually 1/9, then saying that 1/9 is greater than 1/15 or something along those lines, because 1/15 was the chance of our first outcome when it was not replaced. So now moving on, question 21. Circle any fractions that are equivalent to 0.36 recurring. Well, if we start off with our algebraic proof, we don't have a calculator, so we're going to have to use our knowledge of 0.36 recurring being equal to, let's just say, x. So 0.36 recurring is equal to x. Now, if you remember how to do this one, the biggest mistake is maybe you're multiplying by 10. You have to realize that because there are 2 of these numbers recurring, it means we're going to multiply by 10 to the power of 2. So instead of multiplying by 10, if there were 2 numbers recurring, that's the power that you multiply your x by. So if it was 0.362 and they were all recurring, you would have to multiply x by 10 to the power of 3, so 1,000. But in this scenario, we've got 2 digits recurring, so we're going to multiply it by 10 to the power of 2, so 100. So 100x. So if we multiply it by 100 on both sides, 0.36 both recurring would turn into, if everything moves to the left by 2, because we're multiplying by 100, remember the decimal point stays where it is, 36.36 recurring. I could have done the recurring digits up here, but it is a bit easier to follow if we put the dots above the 3 and 6 here. So now, if we want to work out what the fraction is that is equivalent to 0.36 recurring, we will need to do this. If we know that 100x is 36.36 and we know that x is equal to 0.36 recurring, what we can do is actually say, well, let's call this one number 1, equation 1, and we'll call this equation 2. So this is equation 1, this is equation 2. We can do 1 take away 2, which would be 36.36 recurring, take away 0.36 recurring. This would carry on forever, and this would carry on forever. Well, in this case, you'd be left with 36. The 3 6's that would forever carry on, would all cancel out, so this you'd end up with 36. Looking at this side of the equation, 1 was 100x. So if we now take away equation 2, like we did before, we'll be left with 99x. 100x take away x, 99x. Which means that 36 equals 99x. If 36 equals 99x, then we can divide by the coefficient of x. So if we divide by 99, 36 over 99 will become 36 over 99. 36 divided by 99 can be rewritten like that. And 99 divided by 99 is 1, so 1x. So this has to be equivalent. What they've done here is try to check that you are concentrating enough to realize that actually one of the other fractions is identical to 36 over 99. So a lot of people probably would have stopped there and said, okay, that's the answer. That is an answer, so therefore, I've finished this one. It's only worth 1 mark. But in actual fact, you needed to circle any fractions that are equivalent. There is another one that is equivalent. 36 over 99 can be simplified. You might notice that they're both in the 9 times tables. 36 divided by 9, 4. 99 divided by 9, 11. So 4 over 11 is also the same. You need to circle both of them to get all the marks. Looking at question 22, and we are looking into functions. This is new to the AQA syllabus, and one that hopefully you didn't find too hard. Now, FGX, remember, FGX means whatever equation I have for G, I'm putting it into my F equation. So whatever I had to G, for G, I put it into my F equation. So we're kind of reading from right to left. Well, if G is x plus 5, then that replaces your x. So it replaces x in the F equation. So now instead of saying x squared, we're actually going to say x plus 5 squared. Okay, so just to recap that, we're putting G, the equation for G replaces our x in the F equation. So we have g of x, which is x plus 5, and that's going to replace our x in the F equation because it's f of g of x. So therefore, it's going to be 2, open brackets, x plus 5 all squared. So 2, open brackets, x plus 5 all squared, which you can see is going to be this one. And that's the mark. Looking at the last question on the paper, 6 marker, so worth just under 10% of the paper. Diagram shows a right angled triangle. 4 of these triangles are used to make a shaded square as shown. Work out the area of the shaded square. So we want to work out the area of the shaded square. Well, to work out the area of a square, what we need is the length, and we multiply it by the other length. Okay, square, we know all sides are the same length, so it's actually just, if you've got one of the sides, you can just square it, and that's the area of a square. Sounds a lot easier than it actually is for this. We know that this length here, if we look at this example, is 6. We know that this length here is 4, but we don't know that. And that's going to be very important, because if we want to work out what this length of the square is, we're going to need to know what all of this is, and then we can actually take away this part. The whole thing minus this part, which we know is 4, because this is just another one of those triangles, just lays sideways, or on its point. So we just take away 4. Whenever we work out what that is, just take away 4. So let's work out what that is. How would we do that? Right angled triangle. We have 2 of the sides. We want to work out one of the missing sides. Pythagoras' theorem. A squared plus b squared equals c squared. C is always the longest side, remember. So C is always the longest side, the hypotenuse, or opposite the right angle. Another way of remembering. So for this, instead of a squared plus b squared equals c squared, we could just rearrange that to get c squared equals a squared plus b squared. But if we're looking for a, and it doesn't matter which one I've called a, then a squared equals c squared. If I've taken away b squared from both sides, it's going to be minus b squared. So c squared, take away b squared, will give you a squared. Well, what is c? C is 6, and b is 4. 6 squared is 36, 4 squared is 16. Take them away, so 20 is a squared, so we need to square root both sides. So the square root of 20 equals a. And the square root of 20 can be simplified to the square root of 4 times by the square root of 5. Remember from earlier, our third simplification. Square root of 4 is 2, and so it's going to be 2 root 5. So you could have said, and I'll tell you where the marks are now, the first mark was for getting up to 6 squared minus 4 squared, so that's your first mark. Your second mark was for getting either root 20 or 2 root 5. It's going to be easier later on if you've simplified this though. Okay, so 2 root 5 might be a bit easier to deal with, so we simplify that third, but either one of them would have given you the mark. So that's 2 out of 6. To work out the next bit, we're going to have to remember what we said earlier about how we work out the length of this part of the square. So this part here. Remember, it was the whole thing and then take away that length there. So the whole thing, so the whole length there we just worked out is 2 root 5. So it's 2 root 5. Take away that length there, which we said was 4. Okay, that so far isn't actually enough to get you another mark. What you have to do is, like we said, L squared is the area of the square, so that length multiplied by that length, which will be the same. So we can just square it. 2 root 5 minus 4 multiplied by 2 root 5 minus 4. So we're going to have to expand these brackets. So 2 root 5 minus 4, 2 root 5 minus 4, 2 root 5, it doesn't matter how you do this, you might want to do this by making the grid method. So I'll give myself some space just so I know that we are meant to be looking at using the grid method for our quadratic expansion when we've got them in factorized pro forma. So let's go write it this way: 2 root 5 and 2 root 5, and then minus 4 and minus 4. So fill out your grid method. Root 4 times root 4, first of all, is going to give you positive 16. Minus 4 times root 2 root 5, minus 4 times 2 root 5 is going to give you minus 2 times 4, which would be 8. So minus 8 root 5. You get the same over here for 2 root 5 times minus 4. 2 times minus 4 is going to give you minus 8. So minus 8 root 5. And then 2 root 5 multiplied by 2 root 5 is going to give you 2 times 2, which is 4. And then root 5 times root 5, which will give you 5. Just like if you have root 3 times by root 3, that will make 3. Or if you have root 9 times by root 9, that will give you 9. Remember, root 9 is 3, root 9 is 3, so what we're saying here is 3 times 3 is 9. By this same logic over here, root 5 times root 5 will give you 5. And root 9 times root 9 is 9, root 3 times root 3 is 3, so therefore 4 times 5, which 4 times 5, 20. So if you simplify this to get, so if we wrote out 20 minus 16 root 5 plus 16, there's your next mark. So when you've expanded that, so that's our fourth mark. So our third mark was for, if I didn't mention, 2 root 5 minus 4 all squared. So for putting that, we got our third mark. Fourth mark was for writing it like this. And then the fifth mark, which seems a bit strange, is for 20 plus 16, so simplifying it, 36 minus 16 root 5. So our fifth mark is for writing it in this simplified form. And also, actually, our sixth mark was given here as well. Because if you kept it in root 20, so if I kept it like this guy in root 20, and then did root 20 times root 20, and ended up getting 20 over here, but then minus 4 times root 20, which would have given you minus 4 root 20, and then another minus 4 root 20, and then plus 16. If you wrote it, ended up writing it like that, like a few of you might have done, that would have given you one of the marks, but you needed to simplify that, which is where the second mark came from, to give you either 36 minus 16 root 5, or you could have gone further and actually factorised that into, if I just do this final bit in red, into, well, 4 is a factor of 36 and 16, it's actually the highest common factor. So 4 open brackets, 9 minus 4 root 5. Okay, either one of those would have given you the same 6th mark, but that's how you should have finished off the paper.